Hey guys, I've had a couple of requests for a podcast from worksheet 4 in unit 3. So here's question 3 from worksheet 4. The first thing that we do is draw a heating or cooling curve. And when we read this question, we see that we're going to have a soda that's placed in a freezer. And we're going to cool that soda from 25 degrees Celsius down to negative 12 degrees Celsius. So that's going to be a cooling curve. So I'm going to sketch that over here, where this is 0, and I'm going to put this at 25, and this is degrees Celsius, this is going to be time, and I hope that you recognize that if we're going to go below 0, that we're going to have a phase change. So I'm going to sketch. I'm going to have a decrease in temperature here between 25 and 0. It's going to plateau at 0 as it undergoes the phase change, and then it's going to drop down again, and I think we're going to go down to negative 12. Okay, well, first things first, we are going to look at the curve, and you should see 3 distinct regions on the graph, and that should tell you that you're going to have 3 separate problems you're going to solve for. So here we have Q1. I'm going to label Q1 the part of the graph that's going from 25 to 0. And I'm going to go ahead and I'm going to label the plateau. I'm going to call that Q2. And then I'm going to call this bottom part Q3. Okay, so when we start the problem, looking at Q1, water is in the liquid phase between 25 degrees Celsius and 0 degrees Celsius. So that means that for Q1, I'm going to be using the specific heat of water in the liquid phase, which is 4.18 joules for every 1 gram, 1 degree Celsius. I'm going to compare to that. So I am trying to solve to see how much energy is removed, so I'm going to be solving for joules, and I'm going to need to find how much does the soda weigh, and in the problem it tells me right here that mass is 340 grams, so I'm going to put 340 grams, and I'm changing the temperature from 25 to 0, so that's a decrease in temperature, so it's negative 25 degrees Celsius. Okay, so I'm going to, real quickly, I'm going to cross multiply. It's going to be 4.18 times 340 times negative 25. So 4.18 times 340 times negative 25. It's going to give me, when I multiply that out, I get 35,530, and that would be joules. And then if I round to correct sig figs, should get 36,000. Okay, so looking over at the next part of the graph, I have this plateau here, which is a phase change. And if you look on your worksheet, you should see that the heat of fusion for ice is 334 joules for every 1 gram. That's a 4. So I need to figure out how many joules I'm going to remove if I have 340 grams. So I'm going to cross multiply again, 334 times 340. And I get 113,560 joules, which with the correct sig figs is 110,000 joules. So this right here is corresponding to Q2, this is corresponding to Q1, and I need to go to the next slide in order to calculate Q3. Okay, let's recreate our curve real quick. Remember that we're going from 25 to 0 when we're phase change at a plateau, and then we're going to go down to negative 12. We called this Q1, which we solved for and discovered that it was equal to 36,000. We solved for Q2, which we found was equal to 110,000. And now we need to solve for Q1. Or I'm sorry, Q3. So Q3, we are looking at a cooling of water when it's in the solid phase. So I'm going to be using the specific heat of ice, which is 2.1 joules for every gram degree Celsius. So I'm going to be solving for how much energy that is going to use, and the mass hasn't changed. It's 340 grams, and the change in temperature is 12 degrees, and it's cooling, so it's a negative 12 degrees. So each of these is actually negative because it's a cooling curve, so we're removing the energy. So if I solve for that, I'm going to have 2.1 times 340 times negative 12, and that equals 8,568 joules. And with the correct sig figs, that would round to 8,600 joules. Okay, so that's my Q3. Now, to get the total amount of energy removed, I'm going to add these three values together. So total together, this is equal to big Q. And so negative 36,000 plus negative 110,000 plus negative 8,600 joules is equal to, let's see, 154,600 joules, which in kilojoules would be 154.6 kilojoules.